Welcome to EDU World Space.
Hello, this is instructor Nicole. So a quick sketch showing our canoers paddling up the river, and at some point they drop their bottle. Label this the drop point. But they continue paddling at constant pace for 60 minutes or 1 hour. And in that time, they go a distance of 2 kilometers. So we have a rate here, a velocity of the paddlers in the canoe. Let's say VP of their paddling velocity. But remember, this river has a current. They are going upstream, so the river current has a velocity as well. Let's call this VR. So this 2, the difference is their paddling minus the river rate. That is what actually equals 2. All right, so as they continue paddling up the river at this rate, their bottle is floating downriver at the same velocity of the river because it's just floating. So its velocity is VR. Now we know this distance upriver that they paddle is 2 kilometers, and we're told this distance for them to get back to the bottle pickup point is 5 kilometers. We don't know the time that it takes for them to get back there, but we do know that it was an hour that they were paddling upstream. So it was drifting for an hour already. So it's 1 plus the time the paddlers come back to them. So we can write the equation for the velocity of the river here as the distance of 3 kilometers, because that's the total distance minus the upstream distance the canoers paddled, divided by the rate of 1 plus t hours. And of course, the 3 is in kilometers. So how about the canoe? In the same time period here, this canoe went 5 kilometers during this unknown time period. But we do know, remember, the total velocity of the canoe is the paddling plus the distance of the river. And this time they're going upriver. So we will have the velocity of their paddling plus the velocity of the river itself. So right above, we see that VP minus VR equals 2. So if I rearrange this a little bit, I have VP equal to 2 plus VR. So let me replace this with 2 plus VR. And then we have plus our other VR equal to 5 over T, which we can simplify to 2 plus 2 VR equal 5 over T. And I can solve this for T as such. 2T, actually, that will be not necessary. Don't need to do that distribution, because if we're solving for T, we're just going to divide by this, giving us T equal to 5 over 2 plus 2 VR. And if I rearrange this equation for T as well, let's multiply by 1 plus T here. That will be equal to 3. And this time we will distribute the VR plus VRT equal to 3. And then subtracting VR, we get VRT equals 3 minus VR. And dividing by VR, we get t equals 3 over VR minus VR over VR, or t is equal to 3 over VR minus 1, giving us two equations in terms of t. So we can set these two equal to each other. 3 over VR minus 1 is equal to 5 over 2 plus 2 VR. I don't know why this R turned into a 2, but there we have it. We're getting there. Well, let's go ahead and start solving this for VR, multiplying by that VR on both sides, giving us 3 minus VR here equal to 5 VR over 2 plus 2 VR. Now we'll need to multiply by this 2 plus 2 VR. So you can probably start to see we're going to get a quadratic, as these cancel out, and our 2 times 3 is 6, minus 2VR plus 6VR minus 2VR squared equal to 5VR. So if I subtract this 5VR, we have 6 minus 7VR plus 6VR, giving us negative VR minus 2VR squared equal 0. VR, I apologize, I keep writing the 2. All right, and this will factor into negative 2x plus 3, x plus 2. So we either have negative 2x plus 3 equals 0 or x plus 2 equals 0, which gives us negative 1, which is not applicable in this situation. So we have negative 2x plus 3 equals 0. Subtracting 3 gives us negative 2x equal to negative 3. Dividing both sides by negative 2, we get x, or our value for the river. Sorry, just out of habit I use an x, but this is our VR. We have 1.5 equals the velocity of the river. So for part B, for the total velocity of the canoe, remember it is the velocity of the river plus the velocity of the paddling. So for the moving river, we have 1.5 times the velocity of the paddling. So in a still river, we would have to subtract that 1.5 kilometers per hour to be equivalent. Or said in other words, you would have to paddle 1.5 kilometers per hour faster to have equivalent canoe speed in a still lake.